last lecture. Data types are important because you have to provide this when you declare a variable. And they tell the actual compiler how much memory you want to create. So it's specific to size as well. So the compiler needs this information, but let's talk about the ones that are supported by the C programming language. Up until this point, we know that C has many different types of variables that have different types of data. We know that from creating and initializing variables, you can have types to store integers, numbers, essentially. You can have types that store non-integer numeric variables. Things like the scientific notation or things like booleans, which is true and false values. And then you also have data that needs to be stored, such as characters, either a single character or many characters, which is referred to as a string. But we know that we have these different type of data. Again, for a C program to be powerful, it's going to need to manipulate data. And it's going to need to manipulate all different types of data. So some of the examples that C support the basic data types, there are many data types in C, but the basic ones that we are going to talk about today in this lecture are the int. And remember, these data types are special keywords. So when you say int in a C program, the compiler is going to know that, oh, this is a data type. So we want to talk about int, float, double, char, or these are the main ones that you are going to use. And there's different variations of those depending again on the type of data you want to store and how big the data is. So the difference between these types is the amount of memory. That's all the data types in specifying the data types is about. It's about the memory that needs to be allocated, and it varies depending on what type of architecture you have. But the memory and the amount is going to determine the range of the values that can be stored. So the amount of storage that is allocated to store particular type of data is important to the compiler. It all depends on the computers you are running, and this is referred to as machine dependent. So if I wanted to see a program on a Linux system with different hardware versus a Windows system with certain hardware, an integer may be 4 types in memory or maybe 8 bytes. Again, it depends. So it's dependent on the machine you are running, how much memory is allocated depending on the data that you which want to store. So you know an integer might take up 32 bits, which is 4 bytes, or it make up 8. So first, let's talk about the int. This is one of the most widely used data types. It's a data type that can store integral values that do not contain decimal places, whole numbers. This is when you would identify this data types when you create a variable into stored number. You can also put a minus sign preceding the data type, invert in the variable, and that indicates that the value is negative. So if you have a minus sign preceding the actual literal, so what I'm talking about here is when you create the variable and assign it data, if you put a negative number or value, it's negative number. So ints can store negative numbers is basically what this is saying. It's also a signed integer. We'll talk more about what that means, but a signed integer just means that it can be either positive, negative, or 0. And that's why you can put a minus in front of it. If an integer is preceded by 0 in the letter x, so here we are talking about constants. Here we are talking about when you assign data to an int. I'm trying to describe to you the types of data that can be stored in here. And so when you assign data, we know how to assign data to variables because we learned that earlier. We just define the data type and then we assign it using the equals operator. Now you can assign values to this int. You can either assign numbers, which is the most intuitive and easy way to do it, like 15. But you can also assign hexadecimal numbers. The computer in the programming language allows that if you want to assign a hexadecimal number to a variable that stores an integer, you must put the 0 and the x before, and that tells the compiler that this is a hexadecimal number. Hexadecimal number is base 16, so you can store letters. So hexadecimal looks like 0xFEFOD like this. So you may see this occasionally in your program where somebody is assigning a hexadecimal number and you are probably thinking your cell phone int only states a decimal or a whole number, but it can also store different representatives. And so this is one with 0x preceding it, the value 50, 158, negative 10, and 0 all valid examples of constant that you can assign to integer variables. There's no embedded spaces are permitted between the digits. And if you try to assign a value larger than 999, you can't use commas. So don't try to assign a value to a variable named x with 1, 2, comma, 000, comma. You have to do 1, 2, 000 only without comma. Float, another really important data type, one of the basic data types, that is float. This is a variable that can store data for floating point numbers, which means numbers that contain decimal places. So value 3.125.8 and negative 0.001 are valid examples of data that can be assigned to variables of type float. There are also floating point constants in C. This can be expressed in scientific notation. So for example, if you have 1.7 e to the power 4, that's a floating point value. And it's expressed in the scientific notation and represent the value 1.7 to 10 to the power of 4. So that's 17 times 10,000, which would be 17,000. A double, very, very similar to the float. Double is very, very similar to the float. Double the data types that come into float, it is stored decimal numbers, decimal places. The only difference is it's larger. It is larger, so you can store large numbers in double. So that would mean that it collects more data in memory. So you want to use a double whenever the float is not sufficient. It's a too small. So float, I think, stores like say a float stores depending on your architecture. Say a float stores 8 bytes. That means it can store values from like -3 to 000 to a +3 to 000. If you try to represent that same data and memory using a double, you can then store even higher numbers. So you want to use basically twice as many significant digits, going long millions and millions and trillions, whatever, much bigger than a float. So most computers represent a double value using 64 bits, which is 8 bytes. Floats are usually 4 doubles, or I might spoke there. That just means you can store more data. And the way that you would create the variable is you would say double keywords before naming the variable. All floating point constants are taken as double values by the C compiler. So that's by default. If you specifically want to make something a float, you just add an F2. And at the end of it, when you assign it, so to explicitly express a float constant, you just put the F there, 12.5 F underscore 2. This is a data type that can be used to store just the value 0 and 1. You often hear this term Boolean. Boolean data type, Boolean expression in Bool, it's all means true or false. It's a yes or no, 0 or 1. So it's indicated for binary choices essentially. And we are going to talk a lot about Booleans and Boolean expressions when we talk about decision statements. Boolean variables are used in programs that indicate a Boolean condition, a true or false types of that answer. So for example, a variable this type might be used to indicate whether all the data has been read from a file, yes or no, has all the data been read from a file. If it's 0, false, 1, yes, which we'll talk about now. So 0 is used to indicate a false value, or 1 indicate a true value. So even though it's a true or false values, the way that the data is stored in a memory, 0 or 1 is a numeric, but their numerics mean that 0 means false or 1 equals true. So if you were to print out Booleans, you would see value 0 and 1 printed out, not true and false, but they mean true or false. They also can have two values. So here's an example with some data. Let's go ahead and put this in code blocks editor and see how we do it. So here again, we have our basic program and we have our main routine. We know how to declare variables, where we have to provide the data type. Now we know how to declare more than one before we only declare an int. Now we can actually declare something like a float. You just use the float keyword and your intelligence will help you. And then you follow the naming convention. Let's just see again. JSON, and then we can assign it a value. Floats consist of decimal places. So we could say 23.22, and that contains a float, and we assign it. So we are initializing and creating a variable of type float that contains value 23.33. And you notice the semicolon at the end there. We can do the same for double. We have to come up with another name. We could say JSON2. We want to have meaningful names. So we know that here it would just be a large number. So it we like so many. So, and we would also express this with scientific notation. If we wanted, we could put an E plus 11. You know, but that big large number would not be able to be stored in a float, and that's why we would use a double. We can create a bool, and here just Boolean variable. Usually you want a camel case, and then here we could just say true, even though it does not necessarily contain that when you print it out, or we could set it to 1. And then you always want to compile and run your command. Compile or run your command in this code editor. So what you will do here, we could just say true, even though it doesn't necessarily contain that when you print it out, or we set it to 1. And then you always want to compile and run your command. The bool type also usually has been aliased to other names. So you don't always have to just use underscore bool. Depends on the compiler you are using. This actually compiled fine. It just says I am using variables, which gives warnings. Remember, C has different standards. The C89 standard means you have to use underscore Boolean, like we have learned underscoring Boolean with a capital B and so forth. With C99 standard, it allows you to use the true false values in the Boolean data types. 0 means true or 1 means false. Oh, sorry. 0 means false and 1 means true. So you don't have to use underscore boolean and then create a variable my boolean and then set it to equal to 1 or 0, 1 true, 0 false. You don't have to do that with C99. Underscore boolean is only in the C89 standard. So if you are using C99 compiler, you can actually use the boolean data type. All you have to do is you have to say include, and then you can say include standard bool dot h. Include standard boolean dot h. This is the header file. This is going to have a macro that allows you to use different data types, the traditional boolean data types. So when you include standard bool dot h, you can say, now say instead of underscore boolean, you can just say bool, and it's going to recognize that as a data type. Instead of saying 1 or 0, you can say true, or you can say bool, another boolean, and you can say false. So if you don't like using underscore boolean for your data type, which again is not what most languages use, they usually just use something like bool or boolean includes standard bool dot h and specify boolean, and then you can use the true and false keywords in the boolean data type. So other data types, you may ask yourself the question, well, so hey, why do I need more data types? Ask this question yourself. I pretty much talked about numbers. Why do I need to represent numbers in different ways? So we still have not talked about characters, okay, which we are going to talk about. And there's some other data types for characters. But as far as numeric goes, we have talked about numerics, being decimals, non-decimals, int, doubles, and floats. And you would say that probably it is enough. And typically the int is enough. All you need is an int. You will use and quite a bit, but C is a flexible language. And as one of the advantages, there are many other data types where you can represent other integers types, and it gives some flexibility to the programmer. Depending on the use case, depending on the data, it allows it to be even more precise. This is one of the ways that C can become even more efficient. If you have something very, very specific, you can specify a specific data types as part as integral or an integer, and it will make the program run quicker. So it gives the programmer options, flexibility with additional data types. Integer types can vary in ranges, and whether negative numbers can be used. So some of the data types I'm going to talk about in terms of integers, but these also apply to float and doubles, are some keywords that you can assign to the int already, but it's not always required. So you can basically have more specified versions of ints, more specified versions of floats or doubles, or you can use these keywords by themselves. So for example, you could say sort int, that's a data type. I'm going to tell you what that means, or long int or unsigned int or short double or long double. These are all additional data types with these three adjectives. But you also don't need to use the int, float, or doubles with them. You could just say sort, or you could just say long, or just and that will provide a specific data that you can store. But this is all about being more precise and making the program more efficient. Again, you will probably just use int, double, or float for the most part. But when you start getting one more advanced C, you are going to start using sort, long, unsigned, along with the int, double, float. So for example, type sort int or just sort by itself. Like I said, you could use both. It uses less storage than an int, so it can save space. So if you are writing a program that needs a lot of memory and you need the program to be efficient and not use a lot of memory, you can create sorts. So allows that flexibility, makes your code more efficient. If you use a sort as opposed to an int, you don't have to use it sort, but it will use less memory. And the same goes for longs. They use more memory and it's actually larger data. So a long n is going to use more storage than an int, allowing you to store larger integer values, or you say long float, or you can just say long by itself, and that will be larger integer value than you can store. You might ask yourself, why not use a double? Because a double, remember, has decimal scores. So you may want to store that just a really large int. You can use long. So a type long int, another type, or long may use more slogans than long. And again, it all depends on the computer platform you are using, the architecture. You can assign values, use all these different types. A lot of them have a different letters that you can append. So for example, here, if you are assigning a long constant value, you just put the capital L or lowercase l at the end of it, and that will assign that value as a long. Same goes if you are doing some of the sorts. You can also apply suffix at the end to make sure that the compiler explicitly knows what you are dealing with. So type specify can also be applied to doubles. As I mentioned, these sorts and longs, you can say long double, and here we create a long double called as deficit 2017. You can For the long doubles, you can use the capital L, as I mentioned, or lowercase L same way. With ins. As far as the other data types besides short and long that we talked about concerning unsigned, you can set the prefix unsigned to int, double, or floats, and this is used for only variables that have non-negative values. So remember that an int can store non-negative numbers. You just say minus. If you don't want int to store a negative number, you can declare it as an unsigned int or just unsigned, and that will make sure that everything assigned to that is positive. Now, that's how it works in theory. Some compilers don't enforce it, some compilers maybe. But if you were to create an unsigned intent, you try to assign a negative number, the compiler should complain. So unsigned counter, for example, and again, this allows the energy variable to be extended to only allow positive values. It's making your program more efficient by using all of these different data types, these more specified data types for these. Also, there's the signed data type that can be applied to ints, floats, and doubles, or signed int. It can be used with any of the types to make it more explicit. The intent, signed, sort int, sorts, they are all the same. Signed means that it can be negative or positive. So these are just the basic data types that I wanted to talk about. These are the ones you are going to use most of the time, along with a couple more that I'm talking about in the next lecture. You usually don't have to get into using sorts and unsigns and longs unless you are more advanced and you are trying to make your program more efficient. But all these data types, they are provided right before the variable name when you declare the variable, and when you assign